66 million years ago, the dinosaurs ruled the Earth, roaming the ancient continents for millions of years. Little did they know, life as they knew it was about to end. From the asteroid belt between Mars and Jupiter came a mountain-sized space rock on a direct collision course with our planet. It struck, leaving behind a massive crater 115 miles in diameter and 12 miles deep. This impact unleashed a cataclysmic force, leading not only to the extinction of the dinosaurs, but also nearly wiping out all life on Earth. So, what would happen if a similar-sized asteroid, traveling at the same speed, hit Earth today in the same location? We can gain insight by exploring this scenario with our current technology and understanding of such cosmic threats. Would humanity survive? Could we stop this catastrophe? Let's take a closer look at the asteroid that nearly ended all life on our planet. The Chicxulub asteroid is estimated to have been 6.5 miles in diameter and entered Earth's atmosphere at a blistering speed of 45,000 miles per hour. When it struck, it released energy equivalent to about 100 teratons of TNT, comparable to the explosive power of 2 million Hiroshima bombs. Experts suggest that it impacted in the worst possible place, just off the coast of Mexico's Yucatan Peninsula. Had it struck elsewhere, life on Earth might look vastly different today. You might wonder if we would be able to detect such a massive asteroid on a collision course with Earth. The unsettling truth is that astronomers have recently discovered thousands of asteroids, some large enough to destroy entire cities or potentially trigger mass extinction events, moving on unknowable trajectories around the Sun. One known factor is that asteroids are often dark, celestial objects that reflect very little light, making them challenging to detect. Consider Oumuamua, the Solar System's first interstellar visitor. This cigar-shaped rock, 400 meters long and 360 meters wide, was only spotted after it passed the Sun, reflecting just 10% of its light. It's much smaller than the Chicxulub asteroid, but no one had any idea it was out there. On October 14, 2017, it passed Earth at about 85,000 miles per hour, coming within 15 million miles or 0.16 astronomical units, a close shave in cosmic terms. Currently, there are no existing telescopes on Earth capable of tracking objects hiding behind the Sun, and our technology lacks reliable methods to destroy or divert a massive asteroid. If we were to spot a mountain-sized rock hurtling towards us at high speed, our options for response would be limited, leaving us to prepare for the impact. Let's envision this doomsday scenario. Astronomers detect an unusual object in the sky, a black spot against the Sun that grows larger each hour. They estimate it to be a giant asteroid 6.5 miles in diameter, headed straight for Earth at 45,000 miles per hour, located about 90 million miles away. We would have roughly 83 days until impact. In an effort to prevent mass panic, governments would try to keep the situation under wraps, but it's only a matter of time before someone figures it out or an amateur astronomer makes the discovery. Global space agencies collaborate, attempting to devise a plan to either destroy or redirect the asteroid. Unfortunately, time is not on their side. The gravity tractor concept is raised, but there isn't enough time to design the spacecraft, plan its trajectory, and execute the necessary maneuvers. Asteroids typically move at speeds between 38,000 to 59,000 miles per hour, and redirecting an object as large as a mountain, traveling faster than a bullet, is a monumental task. Launching nuclear weapons is also considered, but no one can guarantee the effectiveness of this approach. It could shatter the asteroid into smaller fragments, creating a multitude of dangerous impacts across the globe. As news of the asteroid spreads, chaos ensues. Panic grips the population as the reality of an impending asteroid impact settles in. People rush to stockpile food, water, and survival supplies, while authorities struggle to maintain order. Highways become jammed with vehicles trying to escape the impact zone, leading to widespread unrest and desperation. Civilization, as we know it, appears to be on the brink of collapse. Hours before impact, the asteroid blazes across the sky like a giant fireball, entering the atmosphere at incredible speed. The intense friction generates an enormous air blast, heating the asteroid to extreme temperatures. The shock wave travels outward, causing a deafening sonic boom that shatters windows and flattens forests for thousands of miles. Electromagnetic disturbances affect electronic equipment, and communication satellites in orbit are destroyed. In an instant, the world is plunged into silence. When the asteroid finally strikes Earth, the energy released is equivalent to millions of 50-megaton nuclear bombs. The impact causes massive earthquakes that exceed 11 on the Richter scale, triggering tsunamis and sending waves nearly 3 miles high crashing into coastal regions. A colossal plume of molten material is ejected into the atmosphere. With temperatures hotter than the surface of the sun, superheated winds radiate outward, shredding vegetation and vaporizing any living creature in their path. The devastation is unimaginable. Forest fires rage, and the atmosphere fills with dust and ash, blocking sunlight and plunging the planet into darkness. This results in a nuclear winter effect, drastically lowering global temperatures. Acid rain pours down, and the dust particles obstruct sunlight, disrupting photosynthesis and leading to the demise of most plant life. For the unfortunate humans who fail to find shelter deep underground, survival chances would be close to zero. The psychological toll of such an event would be immense. Fear alone could claim many lives. Those who manage to endure the impact face the daunting challenge of surviving in a ravaged world. Food and water shortages would emerge in the weeks following the impact, and supply chains would be completely disrupted. Most livestock would perish, leading to a further collapse of food sources. Survivors would likely remain underground for months, as the outside world transforms into a post-apocalyptic landscape. Cities near the impact site would lie in ruins, and the human toll would be catastrophic, with most inhabitants perishing from the initial blast, tsunamis, fires, or subsequent environmental changes. In the aftermath, survivors would have to contend with a harsh and inhospitable environment, grappling with weakened immune systems and increased susceptibility to diseases. Establishing community health centers would be crucial, as would finding ways to generate electricity amidst the devastation. Despite the dire circumstances, humanity's resilience and ingenuity could shine through. Indoor farming with hydroponics might provide sustenance, and renewable energy sources could be developed to replace dwindling fossil fuel reserves. With time and cooperation, rebuilding efforts could commence, leading to a transformed world. Decades, or even centuries may pass before full recovery occurs, but the experience would certainly change our perspective on life. So, now it's your turn to weigh in. What do you think would happen? Could humanity truly survive such an asteroid impact today? What would your plans be if you discovered a huge asteroid was on its way to Earth? We look forward to reading your comments. Stay tuned for more, and thanks for watching.